Hey guys, Professor Calculus is here. Today in this video I get an interesting integral for you. That is the integral from negative infinity to infinity of x over sinh of x. Now, we can write this integral as the integral from 2 times the integral from 0 to infinity over of x over sinh of x, since x over sinh of x is an even function. So I'm going to define my I to be to be the integral from 0 to infinity of x over sinh of x dx. Now, recall that the sinh of x is defined as the following formula: e to the x minus e to the negative x over, and write it better, e to the x minus e to the negative x over 2. And if I substitute that in here, I'm gonna get I to be equal to the integral from 0 to infinity of 2x over e to the x minus e to the negative x dx. And my I is going to become to the integral from 0 to infinity of e to the negative x, e to the x minus e to the negative x dx. And I can factor out a e to the negative x here, multiply and divide by e to the negative x, and you'll see later why. So e to the x minus e to the negative x dx. So this is going to get multiplied here, and I'm going to have the integral from 0 to infinity of e to the x e to the negative x over 1 minus e to the negative x squared dx. Now, I'm going to take this thing here, e to the negative x over 1 minus e to the negative x squared, and I'm looking for a series expansion. Now, if you recall, the series for x over 1 minus x squared is the infinite sum from 0 to infinity of x to the 2n plus 1. And if I plug in e to the negative x for here, I'm going to get the infinite sum from 0 to infinity of e to the negative x down to the 2n plus 1. And the infinite sum is gonna get simplified a little. That's gonna be e to the negative 2nx minus x. So I'm gonna do this replacement here, this substitution. It's gonna be 2 the infinite sum and equals 0 to infinity of x e to the negative 2nx minus x. So I'm gonna write it as x e to the negative x 2n plus 1 dx. Now here I'm gonna do another substitution here. I'm gonna let u be equal to x times 2n plus 1, and my du is going to be dx times 2n plus 1. X is going to be u over 2n plus 1, and dx is going to be du over 2n plus 1. And I is going to be 2 the infinite sum from n equals 0 to infinity of u over 2n plus 1 times e to the negative u times du over 2n plus 1. And my I is going to be to the infinite sum from 0 to infinity of 1 over 2n plus 1 squared, the integral from 0 to infinity of u e to the negative u du. Now, if you go and calculate this integral by integration by parts, you're gonna find out that this integral is indeed equal to 1. Thus I can suppress it here and say my integral is twice the infinite sum of 1 over 2n plus 1 squared. Now this infinite sum here is actually another form of Basel problem, the Riemann zeta function, and it is equal to pi squared over 8, and my I is 2 pi squared over 8. I is pi squared over 4, which means the integral from 0 to infinity of x over sinh of x dx is pi squared over 4. Now recall that the integral from negative infinity to infinity was twice the value of this one, which means it was twice the value of pi squared over 4, which means that this integral from negative infinity to infinity of x over sinh of x dx is pi squared over 2 exactly. Thank you for watching this video. Please make sure to like and subscribe, leave comments, and share this video, and I'll see you next video.